Welcome to an important follow-up to the Solving Trigonometric Equations video. This is part 2, where we deal with problems that are a little more complex than the ones we ended with. However, make sure to watch part 1 before you watch this one to see where we've begun. Okay, first problem here. We have this trigonometric equation. We want to solve for x values between negative pi and positive pi. Here's how we begin. Look at this equation and try to unravel it so that you end up with something simpler. Your goal is to end up with just the trig function itself, so just cosine in this case. So first thing, we'll subtract 2 from both sides. We get this. Next, divide by 4 on both sides. You get this. Now we have cosine squared. We can take the square root on both sides to get rid of that square. Once we take the square root, we have root 3 over 2. All of a sudden, what began like this, it looks very familiar to things we've seen already. So now we have a simple trig equation where we are trying to find out what angles will produce x values of root 3 over 2. So in our unit circle, we should be imagining an angle that spins and creates an x value of root 3 over 2. Hopefully you're thinking that angle must be 30 degrees, but let's take a look to confirm. Here's our unit circle. Here's root 3 over 2 as an x value. We can spin that angle to create root 3 over 2 here as your x, this as your x value here. So that means this is root 3 over 2, and this part here would be a half. So that angle is what? And we can also spin in a negative direction to create that same angle with still an x value of root 3 over 2. Notice we went positive and negative because our domain is from negative pi to positive pi. Therefore, to go to pi means to only go to 180. So if we kept spinning this angle to 180, we would never again create an x value of positive root 3 over 2. But if we go in the negative direction, we get to that x value right here. So positive direction, negative direction, and we stop at both locations. So those angles then are pi over 6 and negative pi over 6, because pi over 6 represents 30 degrees in both directions. Let's try another one. This one's a little different. It's the first time we're seeing something where inside, within the sign, we see something multiplying the theta or the x. So we see 2x there. Here's how we begin with these. Look at that compared to the domain you're given here, which doesn't have 2x, it has x. So first thing we have to do is adjust the domain to match what we see in the equation. Here's 2x, so this needs to be 2x. So what we're going to do is multiply this by 2, but that means multiplying this and this also by 2. So what we end up having is that becomes this. We rewrite it in terms of what we see in our equation. So 2x, and this is 720. So now that means we can spin twice around the circle, 360 and again. Okay, so try it. Draw a unit circle and try to create a y value of root 2 over 2. What angles will bring you to that y value within 0 and 720 degrees? Okay, let's check what you came up with. First of all, you can spin 45 degrees. And you have a sine value of that, a y value of root 2 over 2. You can spin further to 45. 135 degrees also brings us to this angle here, which has a y value also of root 2 over 2. And then if you keep spinning, now that we're allowed to spin all the way to 720, we keep going, come around 360, and come back around to here again. Now it's 405, and then back over to here, now it's 495. And after that, we get to 720 and we're done. So within 2 spins, we have 4 possible angles that bring us to this y value of root 2 over 2. But we're not done yet because we have just found out what 2x can be. So now that we know 2x can be those angles, we then divide everything by 2 and bring it back down to x. And we say x can be these values here. So x can only be these angles that are half of these. Important to understand how this works. Take a close look, pause if you need to. Okay, let's look at another one like that. See if you can solve this one without me showing you anything. Let's see if you can figure it out. Let's see what you came up with. So first I'm going to add 2 on both sides. And I noticed there's 2x there. Yeah, that's right. So 2x here, so I'm going to change the domain here. Multiply everything by 2. That's our possible domain now for 2x. Okay, move the 2 over to get 3. Divide by 6 to get this half now. Now we have a sine function that we recognize. We're looking for angles that produce y values of a half. Okay, so looking at your unit circle, we have that angle produces a y value of a half right here. and then this angle also produces a y value of a half right here, positive y value. We can only go to 360, so if we kept spinning around, we would not get to a y value of a half again. But we are also allowed to go negative direction. So now coming around the negative side, we get this angle, and also from the negative side, this angle. So what are those four angles? They are these four angles. However, those four angles are for 2x, because that's what our angle is right now. Our angle here is 2x. So 2x equals those possibilities. Divide by 2, and we have these possibilities for x. And notice that those numbers do fall between negative 180 and 180 because of what the conversions we made. Everything works out. Okay, how about this one? A little bit more complex. Check out what's going on here. We have sine of x over 2 minus cosine of x over 2. X over 2 means we're going to adjust our domain here as well. So the domain is adjusted to this. We divide everything by 2 this time, like this. Now this is interesting. What do we do with this? It's different. We can move the cosine to the other side. So we have sine of x over 2 equals cosine of x over 2. In other words, what angles produce y values and x values that are the same? There's some angles that produce the same x and y values. When are they equal? Well, hopefully you're thinking that's the 45, 45, 90 triangle, because in that triangle, we always have the same x and y values, right? Root 2 over 2 and root 2 over 2. And we have the two positive ones here and the two negative ones here. So this seems to imply that our possibilities are either this angle or this one. However, look at our restriction. We can only go negative 90 and positive 90. So you can only spin up to 90 degrees or negative 90 degrees. So this one here is eliminated from our possibilities, and we're left with only this choice here. So that angle x over 2 that we just solved for is 45 degrees. We know this is a 45, 45, 90. But we now need to adjust this just for x, multiply both sides by 2, and we get this, 90. And that will be our answer for that one, only a single angle. And notice again, the 90 falls between negative 180 and 180. All right, try this one out. This one's a little tougher. Let's take a look. When you look at this, what do you see? Does it look like something? Hopefully you answered that looks like a quadratic equation. We see a sine squared and then just a sine and then just a constant. So let's treat it like a quadratic. Here it is. I'm factoring it. If this was a quadratic, it would be like 2x squared plus 5x minus 3. So factored form is 2x minus 1, x plus 3. Let me show you that. So this looks like this quadratic, 2x squared plus 5x minus 3, which factors into 2x minus 1, x plus 3. So that is what's written here. Instead of x, we have sine x, right? So that's the factored form there. And we know when we have factored form, we just solve each of these for x. So this one would solve to be x equals 1/2. And that's what we see here. Sine x equals 1/2. And this one solved is sine x equals negative 3. So we've solved both of them. Now we have two possibilities. You're thinking, okay, what angles produce a sine value of 1/2? Notice the angles have to be between 0 and 2 pi. So what's the only way to get a value of 1/2? Well, pi over 6, and there's no unit circle here. So at this point, you're visualizing this, pi over 6, and then you keep spinning around the unit circle, and you get to 5 pi over 6, which also gives you a positive y value of 1/2. Now, why are there no solutions for this? This is impossible. In a unit circle, the y value cannot be negative 3, right? It can only be a maximum of negative 1. So this is an impossible situation. If you punch that in your calculator, do an inverse sine of negative 3 and see what happens. You'll get an error. There's no answer for that. Let's try another one just like that. Well, this one's a little different. This is back to the previous ones. Move things around and then solve. Let's see what you get. And check your work here. That has been rearranged into this. Now we're at the point where there's no unit circles being shown. Hopefully you're at the point where you can visualize it just in your mind's eye and you can figure it out. So here we're thinking angles that produce an x value of 1/2. You're imagining that in a unit circle, and you imagined these two angles, hopefully. Over here, this one is one of these quadratic ones. See if you can solve it. Okay, lots of work there. So this quadratic factors like this. Let's see what's happening here. Oh, interesting. This one's a little more involved. Wow, we might have to come back to this one. Definitely more complex, but you're ready for this. Notice in our original, it looks quadratic, but we have a cosine and a sine. So what is happening? Well, I'm glad we're ending with this more challenging one. One last one for you guys to think about. So remember, we have what's called the Pythagorean identity. And the Pythagorean identity can be rearranged. If you rearrange that, you can make a substitution for cosine squared, because cosine squared would be 1 minus sine squared x, and that's what we put here. Now that you have just sine squared in here, it can be looked at as a quadratic. So notice this is multiplied, simplified. Now you have a quadratic like we did in the previous problem, and which can be factored. That factors into 2 sine x plus 1 times sine x minus 1. Solve each of those, you get these answers. Now look at each of those separately and think of each one separately as a unit circle. So for what y values are, sorry, what angles produce negative a half as your y value? Well, there's these angles here. And then what y values, what angles produce a y value of 1? And it is this angle here. That's 90 degrees, right? That's when y is equal to 1. So all our possible angles are here. However, the last thing to consider is the domain was from 0 to 4 pi. These angles that we listed were only from 0 to 2 pi, like if you're spinning once around the circle. So then think, okay, I need to spin once and then a second time around, so it produces 3 more angles. So think about how to get those carefully. This is a great challenging problem. You can do it. Give some brain power to that.